Thursday, if the weather cooperates, if it's like today and nice and sunny, we'll go outside and do our find the northeastern sun. If the weather cooperates. Right now, it looks pretty good. They say partly cloudy. The problem is with the weather forecast, you never know what partly cloudy means. Does partly cloudy mean an occasional sun, or does that mean mostly sun and just a few clouds? So we'll play it by ear and see how it goes. Any questions about that? Oh, by the way, remember I told you had a reading assignment? How many of you went and read the reading assignment? Oh, actually more than I expected. I thought with all the weather and everything, everybody forgot. I'm going to give you a homework assignment that's due Thursday. So you need to do it by then if you haven't done it already, because there's questions on there about the reading assignment. Remember, it's about the girl, Hawksby. Yeah.
Are you going to put it on D2L?
The homework assignment? I'm going to give it to you at the end of class. It's sitting right here.
All right.
Yeah. Now, by the way, on D2L, I do put all the PowerPoints that I have so that when you study for the test, because part of the test will have pictures. And I'll put up a picture and you just have to tell me what it is. Okay, because we see lots of pictures. So I want you to be able to describe the location or what we're looking at. Okay. All right, way back when we had class, see, when it's a Tuesday, Thursday class, you miss one class, it seems like a long time. What were we talking about last Tuesday? About the what?
The Pawnee.
The Pawnee, yeah, we finished up talking about the Pawnee. What did we do after that? I'll give you a hint, we used protractors.
Zenith viewing chamber?
Yeah, we started talking about zenith viewing chambers, and technically what we're looking at is what's called the altitude of the sun. What does altitude mean?
How many degrees above the horizon?
Yeah, how far it is above the horizon. Good. And we talked about it last time. And when we're talking about altitude of the sun, we almost always talk about when it's at its maximum altitude. Okay? So when the sun rises in the east, it'll be at an altitude of 0. And when it sets in the west, it'll be at altitude of 0. And then it goes, right? If we're facing south, right? It's going to go from east to west. It gets higher, sets, right? Are you with me? Okay. So that maximum position is what we call the maximum altitude. So whenever we're talking about altitude of the sun, we care about its maximum altitude. And for ancient cultures, that was all they would care about too. Measuring somewhere in between is way too complicated because you don't know, it changes different times a year and all kinds of things. But the measuring of the maximum altitude gets important, right? So let's say, can we do this, the altitude for any day of the year? I want to know what the maximum altitude of the sun is today in Commerce, Texas. That's what we're going to do. What is maximum altitude sun on, what is today, February 8th? In Commerce, Texas. How are we going to do this?
Well, I guess the first thing is that we know that the sun goes from its highest position to its lowest position in 6 months.
We do know that.
Sure. For half a year.
Okay. Notice we're going to start with our herb diagram. So draw your herb diagram with your protractor first. That's where we're going to start. When you have a problem like this on the test, which you will, right? I always draw a diagram, okay? Because even if you mess up the problem, if you have your diagram right, I'll give you most of the credit, okay? I care more about what you're doing in the process. The thing that I like about drawing pictures or diagrams of things is that shows a clearer understanding. Then if you just put down a number, I'm like, well, I don't know where that number came from. Okay, and remember, we always draw our pictures with north to the left, south to the right. Most of that's just for convenience because it's easier. You get less confused than if you're flipping it around. It's way easier for me to grade too. Okay. Now, what do we know about Commerce, Texas?
33 degrees north.
Yeah, the latitude here is 33 degrees north, which means where's the North Celestial Pole? For every problem, we have to figure out where the celestial equator is. To get to the celestial equator, we got to figure out where the North Celestial Pole is. So if our latitude is 33 degrees, we go up how many degrees? 33. We've done this numerous times, right? All right, so there is the North Celestial Pole. That angle is 33 degrees. But what we really care about is the celestial equator. Where's the celestial equator? Yeah, get 90 degrees from that, right? So put your protractor along the line to the North Celestial Pole and go 90 degrees. Mark that, that's the celestial equator. Mark that as 90 degrees. That'll always be 90 degrees. And we also need to know the altitude of the celestial equator, right? How many degrees it is from the horizon. Remember, this is the horizon. What's that?
57.
57. All right, we've done that numerous times, right? Just that all has to add up to 180. Why do we care about where the celestial equator is? How do we measure the position of objects in the sky? North or south?
In relation to how far above they are of the celestial equator.
Right. And what do we call that? We have a word for that.
Altitude.
No, altitude is how far from the horizon. On the Earth, we call it latitude, how far we are from the equator. But on the celestial sphere, how far you are is called declination. Good. So declination, how far an object is from celestial equator. That's why we have to draw this picture to figure out where the celestial equator is, because once we have the celestial equator, then we can put the sun on there. Now, the problem is we have to know what the declination of the sun is on February 8th. But we have a way to do that. You got your Skywatchers book. If you don't, you'll need it to do the homework. Page, it's falling apart because I've opened it so many times. Page 117. Is the table of the sun's declination through the year. All right. Now, on what day should the declination be 0? During the equinoxes, good. And when's it at a maximum declination north?
Summer solstice.
Summer solstice. And what is that maximum declination?
33 or 57 degrees.
No. What's the tilt of the Earth?
23.
23.5. So the sun goes from a maximum of 23.5 above to 23.5 below. So no matter where you're on the earth, from summer solstice to winter solstice, the sun changes by 47 degrees on your sky. Doesn't matter where you're on the earth, it always changes by 47. It's just where that is in your sky. Okay, and if you're on the poles, you actually only see half of it. You only see it from 0 to 23 and a half. Okay, all right. But for the other days in between, we can look this up. Now, if you look on your chart here, it doesn't give every day. It gives it like every 5 days. So on here, it says February 9th, which is close enough for us. So February 9th, the declination of the sun is negative 14 degrees, 52 minutes. Okay. So what do we do with that? I got my calculator. All right, I need somebody to help me. We need to convert this to degrees, right? Decimal degrees. Instead of degrees and minutes, I want this in degrees. So how do I convert this? I take 52 and I divide by 60, and then I add it to that, right? Let me have a calculator real quick. What do you get when you do that?
14.867.
667?
867.
867. Thanks. Okay. This is why we had to learn how to do the converting, because the charts are not the same as the way we do our drawing. So where's the sun on my chart?
It's 14.867 degrees below 57 degrees.
Yeah, the negative means it's below the celestial equator, or technically it's south of the celestial equator. So yeah, we're going to go down 14.867 degrees. So put your protractor on your celestial equator, and I'm going to go down 15. If you can do 14.867, you're really precise. But in the calculation, we'll actually keep that. Mark that. That's the position of the sun today at noon. Remember, this is local noon, when the sun's highest in the sky, when it's on the meridian. But what did I ask for? I asked for its altitude. What is altitude?
How high it is above the horizon.
Yeah, and this is the horizon, right? So what I need is that angle right there. How am I going to get that angle?
Subtract.
Yeah, we got 57. We can know that. We can just subtract those two, right? So 57 minus 14.867 is equal to 42.133. That is the answer. Can you do one like that? Should we do another example?
Yes.
All right, let's do another example. Everybody got this? Erase it. I don't have a lot of board space, so it's okay. I try to record these and put them up on the D12, but as you can tell, you can't really see anything anyway. You can hear what I'm saying, but you can't really read it. Just to warn you. Let's do a more interesting. All right, so this is the question. What day of the year will the sun shine through a window located at a altitude of 57 degrees from latitude 42 degrees north? Sounds completely different, but it's the same question I just asked it a different way, right? Before we asked about the altitude of the sun, here I'm giving you the altitude of the sun. We're trying to figure out what the declination of the sun is. From the declination, we can go and figure out what day of the year it is. Okay, so we're kind of working it backwards. How do we start? Curve diagram. So far, so good. We haven't made a mistake yet. What do I do now? What do I know from the problem? Reading it.
The altitude is
Altitude of the sun. I always assume, I know they tell you not to assume, but in this class, I always assume it's above the southern part of the horizon, okay? Because that means we're in the northern hemisphere. And we're extremely northern hemisphere biased. If you weren't in the northern hemisphere, we would tell you, but if we don't tell you, I always just assume you're in the northern hemisphere, right? So we're gonna come up from the south side. We're gonna measure the altitude of the sun is 57 degrees, right? Because that's when it'll shine through the window. So we're gonna just go up 57 degrees. I'm going to mark that. What is that? That's the sun. And we'll label that angle 57 degrees. Okay. Now what do I do? And panic is not an option. What else do we know? Yeah, our latitude is 42 degrees north. That's the latitude of Boston, Massachusetts. How do I know? Because I lived there for 5 years. All right. So what am I going to do with that latitude? What's this allow me to do? Put the, you guys got to speak up more. I know you know.
You can use it to calculate the declination of the sun.
Yeah, you're getting ahead of me. All I want to do with this is put the north celestial pole, right?
Oh yeah.
And it's 42 degrees where? Above the north point of the horizon, right? All I do is say, okay, let's just start drawing things that we know from the reading, right? So we're just going to go up 42 degrees from the north point of the horizon. Go 42 degrees. Here's the north celestial pole. I can't solve anything yet, but I know that because that's the latitude, right? I'm just drawing what I know because of reading the problem. And if I know where this is, then I also know where the celestial equator is. How far away? 90 degrees. Yeah, we're not doing anything different than we did last time. So we're going to go 90 degrees from north celestial pole and mark that point as the celestial equator. Are you still with me? Now, we need to know this. That's the altitude of the celestial equator. How do we get that? Just ignore the sun. The sun doesn't do anything right now. We know that this is 42 and this is 90. So this has to be left over from 180, right? So I'm just going to do 180 minus 90 minus 42, which is 48 degrees. That's 48 degrees. Starting to see how we're going to do this now? What we need to know to look at our chart is the declination of the sun. Okay? The declination of the sun is how far it is from the celestial equator. I need that little angle right there. But that's not hard to get because I know this one. This is 57 and this is 48. So what's that have to be?
9.
Yeah, it's just 57 minus 48 or 9 degrees. Is it positive or negative?
Positive.
Why is it positive?
It's above.
Yeah, it's north of the celestial equator, right? So anything north of the celestial equator is positive. Yes, this is positive. So the sun has a declination of positive 9 degrees. All right. I'm going to trick you here because you get your chart. Now we just look up when it's 9 degrees. Now, because it only does every 5 days or so, there's never a precise one, so you just got to approximate. If I look down here on April 15th, it's at plus 9 degrees, 33 minutes. So it's probably about a day before that. So it's going to occur on April 14th. However, I should have said days. Does it occur again?
After the summer solstice.
Yeah, it does. If I look here, you see on August 28th, it's at 9:56. But on September 2nd, it's 8 degrees. So it has to be between those two. Okay, so I would guess about August 30th. So there's actually 2 answers when the sun is exactly at that altitude. Make sense? The reason there's 2 answers is because, remember, the sun goes all the way up to 23.5 above the celestial equator, and then it comes down. So it's going to pass it going up. It's going to pass that spot coming back down. The only time it occurs once during the year is when it's either at the summer solstice or the winter solstice, at a declination of 23.5 or negative 23.5. Questions? Make sense?
Yes.
Okay, good. All right. Monte ALban. Has anybody ever heard of this place before? All right, it's in southern Mexico. In fact, it's located right here. Google Maps. So it's located right here. Let me just the light this. Can't see that very well. All right, so Monte ALban is right here in southern Mexico. Most people recognize Mexico because Mexico City, remember, is right near the center. This is where Mexico City is up here. So this down here, very southern Mexico. It is at a latitude of 17.045 degrees north. Okay. What does that tell you? If this is less than 23.5 degrees, what does that mean? Means that the sun is going to go through your zenith.
And it'll appear in the northern sky.
Yeah, for a short time, right? But if you're past 23 degrees north, will the sun ever get straight overhead? No, we talked about that last time. For commerce, it'll never get straight overhead because we're at 33 degrees and you got to be within, you got to be at 23.5. So we're 9.5 degrees up. But here, the sun will go straight overhead on certain days. What days will it go straight overhead? What's the declination of the sun have to be?
It has to be 23.5 minus 17.
Now you're making it too complicated. We talked about this last time. For your zenith position, the declination of the sun just has to equal your latitude. So zenith, or I should say sun, is at zenith when its declination is 17.045 degrees. And we can look that up in our chart and see what days that is, or I can just tell you what it is because I have it written down here. That occurs around May 8th and August 5th. Okay. All right. This site, Monte ALban, let me give you a closer view here. So this is still above it. This is up on top of a ridge. It's actually fairly high up, and there are mountains or the valleys fall off to both sides. Okay. And then the ridge runs along it this way here. You can't really tell, but when I show you another picture, it's it'll show you better. This was built around 500 BCE. It was abandoned by around 700 CE. Okay. Now, the people here, we think, were the Zapotecs. I doubt many of you have studied any of pre or history of Central America because it gets very complicated. Have you done some?
Yeah.
Yeah, because when you talk about, most people know about the Mayans and the Aztecs and the Incas down South America, and that's all they know about. But there were lots and lots of groups of people. It's kind of like all history. Different groups of people would advance, get bigger, and then the other ones would take them over and so on. The Zapotecs and the Oltecs and the Toltecs were all people that were around starting before the Mayan people, but then a lot of them got incorporated in, and then they came and go, but some of them stayed on their own. Most of the time we reference it to the Mayan, we're going to talk a lot about the Mayans. And they started around 300 BCE and went to about 1500. Now they never really died out. In fact, there are people that still claim to be Mayan people living in the high mountains, so they still exist. But that their heyday was around 1200 CE for the Mayan people. They started about 200 BCE, give or take. And we'll talk about the Aztecs later too. But the Zapotecs, just remember, they were a group of people before that time. Okay? Very similar though, similar in the style of their buildings and in their architecture, their beliefs, their religious beliefs, so on. All right, so here's a map of Monte ALban. And you'll see right here, it's a very interesting place. And you'll be able to tell when I show you more pictures. It looks like most Mayan ruins, okay? Very similar. And in fact, it may have been part of the Mayan state at one time. Nobody's exactly sure. We don't have a lot of good written history from back then. These are the buildings up here. The most interesting one is building J. They made it a 5-sided building. It looks like a home plate for a baseball, doesn't it? And you notice it's twisted at a weird angle. We have no reason why, but obviously that was done deliberately, because everything else is lined up pretty much along the ridge, okay? Which is a pretty much straight north-south. You see the north here is pretty much a straight north-south ridge. But for what we're talking about, what we care about is over here, building P. Okay. All right. So here is what it looks like. If you're there, this is looking towards the south. So over here, this building back here, this is the building J, the weird twisted one, is out in the middle. Building P is over here. This is towards this platform. Right here, you see there's a series of steps and everything that go up. Very much the same design as you see architecturally in all the Mayan buildings and the Aztec buildings. This whole thing had to be hacked back from the jungle, because down there, the jungle pretty much takes everything out. And if you don't hack it back within a year, it would be gone. You wouldn't even see it. In fact, we think there's lots and lots of ruins that we've never found because they're just under the jungle. And they've never had the money and the time and everything to hack all that back. But that's what we see. Now, these are tourists. You can go see it and you can climb up. You have to climb up the hill to get to it. You'll see school groups and stuff and pictures that come up there all the time too. Okay, this is from the platform, so looking back the other way. This is that building J. That looks like a home plate right here. The building we care about is over here, building P. Okay, why? Because there's a tunnel that goes down into a room underneath. And in that room underneath, right here, this is a drawing of it. I don't have a good picture of it. But you can crawl in this tunnel, go in underneath. You don't really crawl, it's actually full size, you can walk through it. You go over here and you see there they made a hole. They deliberately made a hole through the top of the building that comes down, straight down like this. And it's made perfectly straight up and down. And then they have this like cavity here that they created. We think, we don't know for a fact, but this pretty much looks like what we would call a zenith viewing chamber. So on only 2 days of the year, because this is really long and the hole's only about this big, the sun has to be perfectly lined up for the sunlight to go all the way through that to hit the bottom of this cavity that they created. That only happens 2 days a year. It happens on those days, and that's it. Why would you create a room like this?
Ritual,
For what?
for some kind of ritual.
Maybe. This is just speculation time. What would you think? I mean, it was a lot of work to do this. It's not easy to drill a hole straight down perfectly, especially back then. Even now, it's not real fun.
Religious purpose.
Yeah, we're not exactly sure. But from an astronomical point of view, this makes a great calendar. Because you know every year on these dates, it would exactly line up. So if you weren't sure what day of the year it was, you would like, oh, okay, let's watch the sun. And there was probably some shaman or whatever that would watch this. Their job was to watch the sun and say, oh, this is today. And maybe there's a celebration that after that time. We don't know. We do know that around here is when they would plant crops. Now you can remember, we're in southern Mexico, so they don't have 4 seasons like we do. When you get down closer to the equator, you really have 2 seasons. You have what they call the dry season and the wet season. When there's lots of rain and when there's probably almost no rain. The temperature really doesn't change from all year long. There's not a lot of change at all. Because the sun doesn't vary much. Not like us where it goes from down here all the way up to here. To them, the sun just varies up here. It's still 47 degrees, but it's always up high, so the temperature doesn't vary much. They're also very high up. They're several thousand feet high on top of this ridge. So that keeps it about the same all the time. So even in the summer, you don't get super hot because you're much higher than you are in other places. Okay. We think that this was probably used as a time signal that, hey, we're going to plant the crops about May 8th, because that's when the rainy season was started. That's when your crops grow well. Okay. The crops were not planted up there where they lived. The crops are all planted down in the valley. So why would you build your living place up on the top of a hill when you're planting all your crops down the valley?
Flood.
What's it?
Flood.
Well, possible. It's thousands of feet, so I don't think it ever flooded that much. But for what?
You could watch it and supervise the crops.
Okay, from for what would be bad for your crops? Yeah,
Animals or-
I think you're on the right track. That's what we think too. These were not the only people there. There were many different groups. And the best defensive place you can build is top of a hill, right? It is very hard to attack uphill. And so it's the same way as you see feudal castles in Europe. Is all the crops and everything where they raise the cows and all the plants and everything are outside the castle. But if somebody came to attack, everybody just go inside the castle, and then you could attack, you'd have this strong defensive place. That's why we think they built up on top of the hill. All right. We have another example. How would you pronounce that? It's a little tricky. It's a Mayan word, so it's not any language what we're used to using.
Xochicalco?
Yeah, Xochicalco is the way most people pronounce it nowadays. The X has a sh sound. All right, so Xochicalco is another Venus zenith viewing chamber location. Now it's at a latitude of 18.804 degrees north. Which puts it right here. So here we are. It's not actually that far. Remember, what was the latitude of the other one? 17. Yeah, so we're only about 1.5 degrees further north. Okay, so we're here. We're still in southern Mexico. Okay, but this was built later. This was built around 700 to 900 CE. And we believe this was the Mayan people. Remember, time-wise, this is when the Mayans were doing well. Their empire had expanded and it reached its greatest extent about 1200. And this would have been part of it. It went all the way down, actually further than Mexico did. It was a very large one, but it didn't go all the way to the West Coast. There were different peoples on the other side. And so it was interesting. There's lots of groups of people. Notice again, very similar, because this again was built on the top of a ridge. You see, you come in here, but then you have to hike up to it. This is hard to tell here, but you have to hike up to because it's on top of a hill. They didn't build it down in the valley. And notice the same thing. This is all just jungle essentially, where trees and plants grow continuously all the time if you don't hack them back. One of the most interesting buildings here is this one. Look at the elaborate stonework. This is great. They carved this out of stone about that time. What does this depict? Does anybody tell?
The end of the world.
No, not that we know. But you see this?
A river? A snake?
A snake, yeah. And the snake actually has feathers. That's what this is the feathered serpent god.
Very original.
It's very cool. You know what they did too? This is what's so cool about them. They didn't just put one. They put two mirrored. Look, if you flip this over, it's exactly symmetric going the other way. Okay. All right. Anybody study Mayan culture? What's their main god? See, I'm putting you on the spot here. He was the feathered serpent god. His name was Kukulkan. Now, the Aztecs, which came later, had another god, which we think they just stole. They kind of did like the Romans did. They stole other gods from the Greeks and just changed their names. The Aztecs pretty much stole their ones from the Mayans and just changed the names. They had a god called Quetzalcoatl. Have you heard of that one? Yeah, that's the Aztec similar to Kukulkan. Now we'll come back to the Temple of Kukulkan when we talk more about the Mayans. But we think that that is a depiction of it because he's depicted as a feathered serpent. And when you get to the Mayan people, they'll all have these weird, strange heads and all that. Those are just depictions that they used to represent their different gods, different things happening. We see that in the same thing with the Egyptians. All of them have weird heads like, jaguars and ibises and all kinds of stuff. Well, that doesn't mean that they thought there were people walking around with weird heads. It's actually a depiction of who those people were. Okay. All right. Just want to show you this because I thought that was a very cool building. But if we go over on this place, there's a cave that you walk in over here. Walk in over here, I should do it this way. This is a side view here. And you walk into this chamber that they dug, and they dug this chamber out of the rock. Then they made a hole straight up. What's even more impressive about this one than the one at Monte ALban is this is a lot longer. This is in meters. So from the top here where they started to make the hole, where they dug this hole through the rock, is 9.75 meters. How far is that?
It's like almost 30 feet.
Yeah, about 30 feet. You know what? That's about from the top of the dome in here to the floor.
Oh, wow.
They dug a hole through this rock straight down. It's about this big around. To do what? Well, we think it's the same thing. We have no other idea. But we think it's a zenith viewing chamber. Again, because they're at a latitude that's less than 23.5, the sun goes directly overhead on those days. And on this case, because their latitude is slightly different, this occurs about May 15th and July 29th. Again, we think May 15th signifies planting of the crops. But we really don't know for sure. Now, the Mayans actually left us written language, which is nice. But the truth is, we don't actually have all of Mayan symbols and everything deciphered yet. If you still wanted to study a language that's not been figured out, the Mayan language has not been completely figured out. Parts of it have, but not totally. And the problem with the Mayan language is we lost most of the texts and stuff. They're all gone. So I'll talk about later. So there's not a lot left. The only things that are left are things that are carved in stone. All right, but this is it. Here we are. Chamber, giant hole, all the way up to the top. This is in centimeters or parts of a meter. So what this says is this is, instead of 108, that's 108 millimeters or about 10 centimeters across. That's how big the hole is. Okay. And you'll see it's kind of cool because this is what it looks like when you go underneath it and you shoot a picture up through the hole. Okay, you see this? So they built this so it wouldn't collapse. This is rocks with mortar. Remember, they were good with stones. And this is what it looks like. The sun's directly overhead. Isn't that cool? Now, it doesn't look like this quite with your eye. This is one of those, photography things. If you take a long exposure, you get a nice beam. You would see it, but it wouldn't be quite as definite as it is in this picture. But that's what occurs on these days. And it can only be on these days because that tube is so long. Any other day, if the sun's off at all, the sun will hit the side of it, but won't go all the way through. So it really is a very, very good calendar for measuring exactly the days of the year. Questions about any of those? They had metal tools. They had metal, they had swords and stuff. They had bow and arrows, and yeah, they were fairly sophisticated. So it wasn't Stone Age. Yeah. Well, we'll get to places like Stonehenge, which was Stone Age, but this, so they used metal tools. Remember, they had a lot of metal, and that's why the conquistadors showed up and wanted all the gold and all that. How much Middle America history do you get in like high school? Do you get much?
Not really.
Not much at all. Did they talk about Native Americans? Like around here, Caddo Indians and all those kind of things?
A little
A little bit?
They
Okay.
glance over it.
Yeah, a little bit, huh? Oh, actually, I don't have the one I want. All right, we're going to jump completely across the globe. I gotta put on my glasses. We're going to a place, or a guy, actually, it's the name of a person. His name is Gao Xiaojing. He was a Chinese astronomer. Now, if you look up Gao Xiaojing, this is spelled like 5 different ways. Sometimes they put these together and it becomes one word. Sometimes it's 3 different words. Sometimes they spell this with a J instead of a G. All the same guy. It's just the way history happens sometimes. It all gets kind of changed. Gao Xiaojing was a Chinese astronomer. If you know your Chinese history, do we know our Chinese history? Probably knew less of that, right? Chinese history is when the Chinese dynasty, or the Qin dynasty started, which is what China's named after, was around, give or take, 200-300 BCE. And that dynasty has lasted for several thousand years. In fact, it wasn't until communism overthrew when the last emperor went away, which is about 1950s, that they quit having this emperor over China. Okay, so it was the longest one on the earth, essentially. But they were really into astronomy, and the emperor at the time would have a court astronomer. An astronomer, and the astronomer's job was to predict things like eclipses, to interpret things like comets and stuff, because they believed in astrology, Meaning, oh, if the comet's here, that means the Mongols are going to attack us or something like that, or it's a good time to invade Japan or whatever their political goals were at the time. It's always nice to have an astrologer to tell you, oh, that's a good time to do that or a bad time to do that or whatever. But they would also study the stars. And one of the things that the job of the astronomer was to keep track of the days of the year. Well, Gao Xiaojing realized that the altitude of the sun changed daily. And if you can measure that very precisely, you can measure exactly when it gets back to the same position, you can exactly measure, or as close as you could, the length of a year, and you can predict exactly when these things were going to occur that occur every year, like the solstices, the equinoxes, those kind of things. So that's what he did. Gao Xiaojing, and he, to give me a little, some more information, he was around, he lived around 1250 CE. And he built a tower and he built it in Yangchaicheng or Guchang, which used to be the center of China, the government center, until they moved that to Peking, okay, which came later. And he built this tower, and the idea behind the tower is that there's no, this is way far north, so there's no, it doesn't ever go through the zenith. But that doesn't matter because he built this tower such that, tower looks like this. Let me show you a picture of the tower. Oh, this was a Chinese writing from about 1000 AD that showed the idea of this, is that as the sun gets higher in the sky during the year, the shadow length changes, which we talked about. He said, okay, the problem with accuracy is it's hard to measure very accurate when it's a very small shadow. The bigger the shadow, the more accurate. So let's make a giant tower and measure the shadow. So that's what he did. Here's his tower. So the tower looks like this, and it has rooms and stuff up here. But what they do is they would put a board across the center right here, and there's a long part that sticks out here. And he made this exactly north-south. So it's what we call a meridian wall or a meridian line. So it's exactly a north-south line. And when the sun would be very high in the sky, like in the summer, then the shadow of the sun would hit a spot right here. But then in winter, when the sun is 47 degrees lower, the shadow would come way out here, and you'd mark those positions. In fact, you can mark every position that the sun is at every day of the year. And then every time you went outside at noon, you looked where the sun was, where the shadow was, you would know what day of the year it was. It's just an elaborate calendar system. More pictures. Oh yeah, see, their picture's way better than mine. Okay. Notice though, he was also wanted precision. It was all about being super precise. And one of the things to make this perfectly accurate is this long part where the shadow hits. There's this long thing hanging out here, right here, which is like 39 stones that he smoothed out, but they have to be perfectly level. Well, back then they didn't have levels like construction people use nowadays, or nowadays they use lasers to make everything precisely level. So what you would do is you carve these little trenches in it, and you filled it up with water, the little trenches. And then water always goes to a nice level. So if the water's leaking out one place, that place is too low, you would raise it up with some shim. If it was too high, you would push it down until the whole thing was perfectly level. So he could get it very precise when he would measure the position of where the shadow would hit. The shadow would come, or the sun would go right through that hole up here in the top of the tower. Here it is, color picture. And what's cool is all he really needed to have was this tall thing up here, but he made this elaborate thing with staircases on both sides. when you're supported by the emperor, money's not the issue. You just say, I want to do it. Now, what did he do? Among other things, among being a calendar, he measured the length of a year. Remember, this was in 1200 CE. This is way before we were that accurate. He measured the length of a year to 365 days, 5 hours, 49 minutes, and 20 seconds. Now, the truth is he wasn't quite as accurate as he thought he was. He was off by about 20 minutes. But that's still pretty impressive because what you had to do was measure the position of the sun and then 365 days later, measure exactly the same position and time that to within a few minutes. It's way more accurate than they were in Europe at the same time. In Europe, the Gregorian calendar, which is the calendar we use now, which is more sophisticated, didn't come around until about the 1500s. So 200 or 300 years later than he came up with this at this time. The other thing is you can use it for the sun, but you can also use it for other things. You can use it for the moon because it can cast a shadow. You just need anything that can cast a shadow. Now, stars usually aren't bright enough to cast a shadow. Questions about Gao Xiao Jing? I think that's all the pictures I have on that. So what did all these have in common? They all had to do with the sun's altitude, right? The sun's altitude. Monte ALban, Xochicalco were both about zenith sun. Gao Xiaojing was the altitude of the sun throughout the year, to use it as a calendar spot. All right, let's call that good for the day. But don't leave. I have homework. And I'll see you Thursday. Remember to grab your towels on your seats and throw on the basket on the way out.